This goes on page 68. Content objective is we will solve problems involving proportional change using concrete models, tables, and proportions. Proportional means corresponding in size or amount to something else. Some examples of proportional relationships would be time and distance when traveling at a constant speed, like so-and-so can travel 40 miles in 2 hours. So how far can they go in 6 hours? Something like that. Or hourly wages. Mike makes $6 an hour, so how many hours will it take for him to earn $36? So can you think of any other examples that would be proportional relationships? Okay, example 1. If a person travels 110 miles in 4 hours, create a table that shows how far the person travels in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 hours. The cool thing about proportional relationships is that when you set them equal to 0, it's going to be 0. So both of the values will be 0. So with proportional relationships, both values will be 0 at the same point. So let's try this. We'll put hours on top, and we'll put miles on bottom. And then we'll go ahead and we'll start filling in this table. So 0 and 0, we know that one already. 1, 2, 3, 4, 5, 6, 7, 8, and then you have to do 9 and 10. So some stuff that we already know is that you can go 110 miles in 4 hours. So if we divide that out, 110 divided by 4, 4 goes into 11 twice. 2 times 4 is 8. So we have that. 4 times 7, 28. So we end up with 27.5 miles per hour. So that means in 1 hour we can go 27.5. So then in order to fill it out, we're going to have to multiply 27.5 by each one of these numbers of hours. So I'm going to go ahead and erase some of this work. That way we have some more space to work in. And I'm going to have you do most of this work yourself, but I'll do at least a couple of them with you. So 27.5 times 2. Okay. So that's 55. So in 2 hours, 55. So then automatically we already know that's going to be 110 right there because that was given to us. So in 3 hours, so 27.5 times 3. And it's going to be a 0.5. So 82.5. 82.5. So I want you to fill in 5, 6, 7, and 8. Here's Tony, our good friend Tony. If Tony makes $70 in 5 hours, find the total amount of money he would earn if he worked for 3, 6, 11, and 20 hours. Show your results in a table. Okay, so we're going to have hours and money in this table that we're setting up. And we know we need to show 3, 6, 11, and 20. So I'm going to set up this table. So Tony makes $70 in 5 hours. So what I'm going to do is I'm going to divide 70 by 5 to find out how much he makes in 1 hour. So 5 goes into 7 once. 1 times 5 is 5. 7 minus 5 is 2. So 14. So 14 times 5 is 70. So that means he makes $14 per hour worked. So in the middle of our table, we're going to have our process. So we're going to do 3 times 14 and that's going to give us a dollar amount. 3 times 14 is 42, if I'm correct, $42. Then we're going to do 6 times 14. So that is actually just going to be doubled this 42, so that's going to be $84. And then 11, so 11 times 14 and 20 times 14. I want you guys to figure those out yourself. So that means you need to do this one and this one. I really like problems like this. So example 3. The two triangles are proportional, so we need to find the value of x. When we have two triangles that are proportional, we can set up a ratio of the sides. So with our little triangle, we see we have a 10 and a 6 for sides. And then what I'm going to do is I'm going to find the corresponding values in our big triangle. So what side, if I'm looking at my little triangle where I had my 10, the corresponding side would be this one right here. So that means I'm going to put x on top because that's where 10 was. So 10 and x are corresponding sides. And then 6 and 12 are going to be corresponding sides. From there, I cross multiply. 10 times 12 is 120. So I have 120 divided by 6 equals x. That's a really lame looking 6 right there. Sorry. 120 divided by 6 is 20. So x equals 20. Okay, another example with triangles. This one's a little bit more complicated because the triangles are pretty much right inside of each other. But what we can do is we can draw two triangles in order to make it work. So we have triangle ABC and triangle DEC. We know that they are proportional because it tells us in the problem. And then we need to find the value of x. So what we can do is let's draw both of these triangles. So this will be my little triangle, my EDC triangle. You can see right here. So on EDC we have a 7 and we have a 15. And then my bigger triangle, my BAC triangle, I'm going to go ahead and draw those. So the BA, it says, is 11. And then the AC is going to be x plus 15. So now I can set up my ratio. So I'm going to have 7 over 15, and that's going to equal the corresponding sides. So 7 and 11 are corresponding. And then we have x plus 15. We do some cross multiplying, and what we see is 7 times x plus 15. That's going to equal 11 times 15, which is 165. 165. Let me move this real quick. Don't get confused by the crazy looking triangles at the top. 165. And then we distribute 7 times x, 7 times 15, so 7x plus 15 equals, oh, just kidding, not plus 15. What did I do wrong? Seven times 15. So 7 times 10 is 70. 7 times 5 is 35, so 105. So 7x plus 105, subtract 105 from both sides. So we see 7x equals 60. Divide both sides by 7. So x equals 60 divided by 7 equals Oh, messed up. 8.57. That's the rounded decimal. One more example, and then I promise we're done. So triangle ABC and triangle DCE are proportional. Which sides are proportional, and what is the value of x? Well, what I meant there was which sides are the corresponding sides. So we see here that we have a 6. So I want to know what corresponds to that side. So 6 corresponds to what on my bigger triangle? 6 corresponds to what on my bigger triangle? And then I also want to know, what does 8 correspond to on the bigger triangle? What does 5 correspond to on the bigger triangle? Well, I think the easiest one to figure out is the 8, because 8 is paired up. 8 clearly is going to be paired up with 12.8 because they're on the longest sides of the triangle. So 12.8 and 8 match up. The 6 matches with the x, and the 5 matches with the 8. So if we're trying to figure out what x equals, we're going to have to use these numbers to set up some sort of proportion. So I'm going to set up the proportion, and then I want you to solve it by yourselves. So let's go like this. So let's say 6 over 5 equals x over 8, and then you solve it from there. Okay, these are tough, but there's going to be more practice in class. Quiz 13, Friday, November 8th. Thank you very much.